Good day and welcome. I'm Mr. Simons. In this lesson, we'll be looking at the cylinder combined with the sphere optimization problem. So they say a satellite is constructed in the shape of a cylinder with a hemisphere at each end. So there I have a hemisphere and a hemisphere. The radius of the cylinder is r meters and its height is h meters. The outer surface area of the satellite is to be coated with heat-resistant material, which is quite expensive. And the volume of the satellite has to be pi over 6 cubic meters. Right, so that part there is a cylinder, and this is a hemisphere. So one hemisphere plus another hemisphere gives me a full sphere. There they give us the equation: outer surface area of a sphere, cylinder, volume of a sphere, volume of a cylinder. So 1.1 show that h equal 1 over 6r squared minus 4r over 3. 1.2 and show that the outer surface area of the satellite can be given as s equal 4 pi r squared over 3 plus pi over 3r. 1.3 calculate the minimum outer surface area of the satellite. So say you can pause here and attempt to answer it and then follow what I've done, but I'll be explaining now. So again, they say show that h equal 1 over sr squared minus 4r. First thing they said, the volume must be pi over 6. So they gave me volume, so I'm going to start with volume. So volume for my cylinder, pi r squared h, plus volume of a sphere, 4 over 3 pi r squared. If you want to, you can half, but yeah, hemisphere and a hemisphere gives me one full sphere. So there my volume equal pi over 6, which then equal pi r squared h plus 4 over 3 pi r cubed. Right, if I take pi r thing, because I have to make h the subject of the formula, take plus 4 over 3 pi r cubed across the equal sign, so that becomes pi over 6 minus 4 over 3 pi r cubed equal pi r squared h. Make h the subject of the formula by dividing by pi r squared. So there I have pi over 6 divided by pi r squared minus 4 pi r cubed divided by 3 pi r squared. Pi divided by pi cancel, leaving 1 behind, and sr squared at the bottom. 4 over 3 stays, pi and pi cancels. I have 3 pi r's radius there. If I take 2 of r's away, I have 1 r left on top. So 1 over 6r squared minus 4r over 3. There's my equation for h as requested. Next problem, and show that the outer surface of Earth's satellite can be given as s equal 4 pi r squared over 3 plus pi over 3r. So for my surface area, it's going to be 4 pi r squared for the outer surface area of the sphere. So those two hemispheres put together. And the curved surface area of the cylinder, 2 pi rh. Take note, I don't have the circle part of the cylinder. There again, I have two unknowns, r and h. So I have to substitute the equation of h, which we found, 1 over 6r squared minus 4r over 3 in the place of h. So that becomes 4 pi r squared plus 2 pi r, 1 over 6r squared minus 4r over 3. If we simplify, I have 4 pi r squared. I simply carry that down. 2 times 1 stays 2 pi r over 6r squared. Positive times negative become negative. 2 times 4 gives me 8. Pi r times r gives me r squared over 3. Alright? Now if you look there, 4 as pi r squared and 8 as pi r squared. So technically they like terms. But to add this fraction to that, the denominators must be the same. So I'm going to introduce 3 here by 4 pi r squared by saying 4 pi r squared times 3 over 3. Minus 8 pi r squared over 3 plus, there 2 goes in itself once, 2 goes in 6 3 times, r there cancels, and I have 1 r left at the bottom. So now I have 12 pi r squared, 3 times 4 gives me 12, so 12 pi r squared minus 8 pi r squared, which gives me 4 pi r squared over 3, plus the pi over 3r left. Right, there I'm just putting r squared on the side, and if I take r up, r negative 1. This I'm doing for finding the derivative purposes. So there's my answer there that I wanted to. I just went a step further. Look at right, so they say calculate the minimum outer surface area of the satellite. So minimum again, first derivative, make it equal to 0. So 2 times 4 gives me 8 pi over 3, 2 minus 1, r1. Negative times positive gives me negative pi over 3. Negative 1 gives me negative 2. Alright? It's equal to 0 for my first derivative, so I differentiated s in relation to r, or differentiate s with respect to r. So that gives me 8 pi over 3r minus pi over 3r squared if I bring it to the bottom. Take the negative across, it becomes pi over 3r squared equal 8 pi over 3. Multiply r squared away, gives me r cubed. So from there I have pi equal 8 pi over 3 and 3. So that gives me 3 pi, 3 times pi over 3 times 8 pi equal r3. Pi and pi cancels, 3 and 3 cancels. So I'm left with 1 over 8. Cube root of 1 over 8 gives me 1 over 2. Now they said calculate the minimum outer surface area, not the minimum value of r. So therefore, my value I got for r must go back in my original equation. So that becomes s 4 pi over 3 half squared plus pi over 3 half to the power negative 1. Punch in your calculator and you'd get the answer of 3,14 meters squared. So hope you enjoy and understand. Wish you nothing but the best. God bless. Like, share, and subscribe. Bye.